Hi everyone, welcome to lecture 9. This is Intro to Machine Learning, and in this video we'll talk about polynomial regression. We'll talk about the mathematical interpretation of polynomial regression and see a complete Python implementation. Okay, so what we have looked at until now is to fit a linear model to a given data set, right? So we have looked at something like this. We had variables, and let's say this is the first feature, this is the second feature, and so on, depending on the number of features I have. Now, depending on the data set, the distribution of the data could be more complex than just fitting a straight line. For example, again, like the housing price data, so this is the prices and this is the square feet. Let's say this is X and this is Y. And let us assume that my data is distributed something like this, and we'll see that in a short while, right? So if I fit a straight line, right, I might get the values of the coefficients for sure, but not as close to the real value, which is my goal, as fitting a polynomial, right? So if I'm able to fit this curve, and obviously I'm taking it too far, we'll not take all points into consideration, but essentially this is leading to fitting not a straight line. So this, obviously the equation for this one is going to be a higher order polynomial, for example something like a quadratic equation, right? So here in a more generalized form, the mathematical representation of that would be some intercept plus, let's say, beta 1 times x1 x, I'm just calling it x, plus beta 2 times x squared, plus so on, depending on how my data looks like, what order polynomial do I want to fit, right? And this would be a better model in many situations, not always, in order to predict certain parameters. Of course, I can, instead of x squared, have a log or a square root, and so on. So there are algorithms that deal with getting the correct features, and if you look at it, I'm creating these new features, right? So maybe calling them dummy features is okay, but essentially with the given feature, with the given values, I'm creating these x and x squares, which are features in themselves, right? Depending on the degree of the polynomial that I'm trying to fit to my data. So we are not dealing with how to create those features right now. We are looking at polynomial regression in the most basic form. So why do we need it? As I said, it's a better fit. Okay, so here is a typo, but that's okay. So it's a better fit sometimes. And then obviously it depends on the data. For example, I took a small set of observations from the simple linear regression data set that we got from Kaggle. And as you can look at it, fitting a straight line versus fitting a polynomial looks better here. Right, so this might lead to better predictions, but then obviously we'll have to go ahead and fit both a straight line, that means use linear regression, versus polynomial regression, and see which one gives us a better prediction. So the question I'm trying to answer using this data set is that if I know some square feet living space, can I predict the price correctly, and how well can I predict it? So what we'll do in this video is, first I'll create a linear model, and then I'll create a polynomial polynomial regression model, and using either of them, like using both of them for a house of size 2320, I'll predict the price using all the data that I have here, right? And I already know the price of this house from my original data set, which is 580,000. So we'll see which one comes closer, the linear or the polynomial. And then as we'll see, we have to select what order polynomial we are trying to fit. Now, the question arises, why do we also call this polynomial regression as polynomial linear regression? And the reason being that the relationship of the dependent variable with the betas, which is the parameter set, is again linear. So notice all the parameters are still linear. So we are trying to find the linear relationship. The only thing that's changed here is that we have these updated feature values, right? So I have x squared and so on. But the relationship between the dependent and other parameters is still linear, and so we call it a linear model. Okay, so going to Python. Let's keep this. And let's go to Spider. So as I said, this is what the data set looks like, and we've seen that plotted already. So I have the square feet and price, and I just like copied some around 19 values from the original data set, right? So that's that. And this goes back to our lecture on linear regression and multiple regression, importing the library. So we already are familiar with all these steps, right? And let me get rid of importing the data set. So first I was using another data set, but then I decided to use the same as the one we've been working with, right? So I named this new file Polynomial. So here I'm reading in the data set, and let's see how X looks like. So these are the X values, right? So these are my features, and then price is my Y, obviously, right? We know how to train a linear model. I'm not repeating that because there's a whole video on that. If you're interested, go back and check that video, right? Now we are interested in training the polynomial regression model and then also visualizing both of them. Okay, so let's start with training the polynomial regression model. How do we do that, right? So so from, again, I'm using the library sklearn, and then there is a class called polynomial features that's going to help us, right? So from sklearn dot preprocessing. Okay, so that's there. Import polynomial features, right? So this is the class that we need in order to create these new set of features that'll have some polynomial values, as we saw in the example that we were looking at. Now I have to obviously create an instance of this this class. So I'm calling it polyreg. You can call it anything, and then the same class, and then it'll ask for how many features do you want. So like what degree features. For example, if I want just two here, if I want an equation of just like having the highest power as 2, then I'll give the value of the parameter, input parameter here, which is degree equals 2, right? So let's create a degree 2 polynomial first, right? So here I'll create that, and then I have to create this new feature set, which is going to be X poly, obviously, and the rest of the stuff stays almost the same. All you have to do is with this poly regression, you have to do a fit transform, as we've been doing until now. So here dot fit transform, and what do you want to fit transform? The original X, obviously. So this is going to create my new features, right? Because I have X and X squared and so on. That's that. And then I'm calling my, so notice I've already created this linear regression model. So I have to name this polynomial regression something else. So I'm calling it linear, again, this is a linear regression model, linear regression 2. Let's call it linear regression 2. And then this is again using the same class, which is the linear regression class. Again, as I said, this is again a linear regression model. The only thing that has changed here is that I've created new set of features which are saved in X poly, right? So that stays the same, and then obviously I have to fit using that X poly, right? Okay, so again, copy this here, dot, and then remember from the linear model we have to fit, and what do we have to fit? The X and the Y. So my features are now X underscore POLY, and then obviously my dependent variable is Y, right? So let's execute this. Let's create this second model as well, because now we have to compare them, right? So this is created, great. Let's visualize the linear model, which was already created. We've created it multiple times, and then you've seen the plotting as well multiple times, so I'm not repeating that. As you can see, this is how we fit the straight line. But now I also want to visualize what happens when I fit a degree 2 here, right? And then we'll predict the results for that particular house that I'm interested in. Okay, so let's first try to visualize, and because we are having more than one, like a higher degree polynomial here, so in order to visualize the polynomial regression results, we have to create higher resolution and curve here, right? So for that, what I'm doing is I'm creating a grid of my features, and then I'm going to go back and reshape them so that I'll get like this X and Y, because remember this X poly has more than one feature right now. So I have to go like bring that back. So that's what essentially I'm doing. So X underscore grid is numpy array dot range, and here I'll take the initial x min, I have to specify the range, and then max of x, that's the entire range. And then what's the resolution? 0.1 is the default, just use that. And then create x underscore grid. Here all I'm doing is I'll just like reshape that, right? So here x dot grid, because this will be a different dimension than, and we need it in a single dimension, right? So that's why I'm doing dot reshape here. So again, x dot grid dot reshape. And then how will I reshape? So remember, reshape, if you remember from the previous video, it's going to take a tuple that's the length of my x grid, right? So len of my x underscore grid, and then you have to specify the axis, come out of this, and then a comma and a 1, right? So this is how we create the x grid. And finally, the plot scatter and everything stays the same, except that let's look at this, plt dot scatter, and the first one is going to be x, obviously, because this is the original data, and then y, let's specify color equals red. That's it. And then the rest of the stuff, okay, so this is this scatter, and then I need a plt dot plot, just like here, and then the title and all of that, right? So I have the scatter, let me have the plt dot plot. Plt dot plot, and that'll have the x grid, which I just created, and let me do that. That's the first argument. Then the next one is going to be my model, so which I named regression underscore 2, right? Yes. And then that should be predicting values, right? So just like with the linear model, we have to do the same here. So predict, and predict what? The polyreg.fit transform that has the grid in it, right? So let me just like copy it from there, fit transform here, and that is going to be here. And instead of x, it should have the grid, right? So let's take the grid because I've transformed it so that I can get what I want. And then color, it depends on, like, this is an optional variable, obviously, because the points are red, I'm taking this as a blue, right? And that's it. And finally, let's have the title, the x label, the y label, and all of that. So I'm just like copying it from here directly. And the title obviously is going to be polynomial regression. Okay, so we're ready to visualize this. Okay. Okay, so it should be, oh, I'm sorry. This has to be a single R-A-R-A-N-G grid. Okay, that's good. We're getting errors. So np.nd array. Where is this? Where am I using that? Let me see. Reshape here. Okay, grid linear regression 2 dot predict, and then this looks okay to me. X grid is x grid reshape. Okay, so it's giving us error here. So that's let me quickly check all the parentheses, right? So this is going to be len x grid x grid. Oh, okay, yes, there is no attribute. Obviously, this has to be an underscore and not a dot. So that's good. Here, so this is the degree 2 polynomial that we fit, and then I just want to show you that you can change the degree here and then also visualize it, right? So here, let me create this again. So I'm creating the model again with degree 4, and then let's try and visualize this again. Right, so notice like there is this overfitting, it's trying to get all the points in place, right? So you can play with that by changing the degree. Now the goal here was to predict new results with the linear regression for this particular house, and then also with the second model that we created that we are calling linear regression 2, right? So let's do the prediction with both of them and see how close we come. And just a reminder, the actual price for that house is 58,000. So let's see, predict. Where is my predict? Here it is. And then how you have to do it is poly underscore reg dot fit transform, and It will take two-dimensional array, if you remember from some of the previous lectures. So the two-dimensional array is this 2, 3, 2, 0, right? So we are predicting with the linear regression and the polynomial regression for the same house and see which one comes closer. Okay, so let's predict with the linear one first. Okay, so this is giving us 548 and the actual price of the house is 58,000. Let's look at this one. Now this is giving us 590K, around 591K. So as you can see, for this particular data set for this particular problem, we come really close to the actual value of the house with the polynomial model as compared to the linear regression. Okay, so with this, I end this video. In the next video, we'll start talking about other important machine learning models.